Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will solve another numerical problem which is based on the concept of capillarity. So what is capillarity? Capillarity is the rise of the liquid inside a thin tube which is placed in the reservoir or a bowl or anything which is original liquid level. If you place a very thin pipe or like a straw or like a cotton wick, then you will notice that there will be rise along the tube or wick of liquid above the original surface, or there may be fall also in some cases. So we will understand this when we will solve the problem. So let's read the problem. Calculate the capillarity effect in millimeters. So we have to find capillarity effect means height, because this is the main effect of the capillary, increase in height inside the tube in millimeter. 4 mm diameter, so diameter D is given as 4 mm, which is equal to 4 into 10 to the power minus 3 meter. Okay, because 1 meter is equal to 1000 mm when immersed in. So there are two conditions. First one is water and second is mercury. The temperature of the liquid is 20 degrees Celsius and the values of the surface tension is water and mercury at 20 degrees Celsius in contact with air. So this is the level of the liquid, and outside this or above this liquid level is air. So surface tension in contact with air are 0.073575 for water, and for mercury it is 0.51. The angle of contact for water, theta, this angle theta you can see, theta for water is 0 degree, and theta for mercury is 130 degree. Take density of water at 20 degrees Celsius as, so rho is 998 kg per meter cube. Okay, so this is the density of water. So what will be the density of water? As we know that for mercury specific gravity is 13.6. okay, so what will be the density of mercury? 13.6 into density of water, which is that normal temperature pressure is 1000 kg per meter cube. So this will be density of mercury. So first of all we will try to derive the expression for this height. What will be the rise in the level of the liquid inside this thin tube? So let's draw the free body diagram. So this is the liquid column which has risen above the original level. So this is H, this is D diameter. So what are the two forces acting? This liquid is in equilibrium at this height, so there will be two forces which are balancing each other. So first one is weight, W, weight of the liquid column. It will try to pull this liquid column at the original level, and there is another force which is surface tension force. So these two forces are balancing each other. Now what is the surface tension force? See, this is called the contact angle, because liquid will be in curvature form, liquid surface. So at center it will be below, and at surface in contact with tube it will be like this. So this angle is called surface tension will act along this direction, and this angle is called angle of contact. So you can see we can break this sigma surface tension in two directions. One is x direction and one is y direction. So in x direction it will be sigma sine theta, and this will be sigma cos theta. So you can see here also it will be sigma sine theta. So these two forces will balance each other, because sigma sine theta will act along perimeter in all direction and it will cancel each other, and sigma cos theta is the force which is sigma cos theta is surface tensor which is trying to lift this liquid column. So what will be surface tension force? Force due to surface tension is equal to, we know, surface tension which is sigma cos theta into line on which it is acting. So what is that line? That line is this cross section perimeter of the tube, which is pi d, pi into d. And what is the force due to gravity? Weight. So what is the weight? Weight is equal to mass into acceleration due to gravity. So mass is density into volume, and this g will be here. So for liquid column, this is liquid for cylindrical column, which this is diameter d. So if this is a cylinder of diameter d and length h, l or h, then its volume will be pi by 4 d square, that is area of cross section, into length. So this is v into rho into g. This is the weight of the liquid. It will be equal to sigma cos theta into pi d. So this d will cancel it, this pi will cancel this pi, so we have to find h. Sorry, here we have written L, but in this case this L is H, so I will write H here. So H is equal to, this 4 will come in this side, 4 sigma cos theta divided by d rho and g. So rho d g. So this is formula for rise in the liquid level inside this tube. So we will calculate this thing, this for two conditions. First one is water. So for water H is equal to H water, suppose HW is equal to 4. We will put all the values. Sigma is 0.0735575 into cos 0 divided by rho density of water is 998 into diameter we have seen already, 4 into 10 to the power minus 3 into acceleration due to gravity is 9.81. So if we will calculate this, you will get H is equal to 7.51 meter. Sorry, 7.51 into 10 to the power minus 3 meter. So if we calculate mm, then we have to multiply by 1000. So this 1000 will cancel this 10 to the power minus 3. So it will become 7.51 meter mm. Sorry. So water will rise by 7.51 mm in this column or in this tube. For mercury, H for mercury is 4 sigma is 0.51 into cos theta, cos 130 divided by rho 13.6 into 1000, which is 13,600, into diameter is same, 4 into 10 to the power minus 3 into acceleration due to gravity will be same, 9.81. So if you will calculate this, then you will get minus 2.46 into 10 to the power minus 3 meter. So if you calculate mm, then you have to multiply by 10 to the power 3 So you will get minus 2.46 mm. Why is it minus? Because cos 130 is minus. So in this case height is minus. What does it mean? It means that liquid will come down here. So it is original tank in which there is liquid at this height, then in capillary tube liquid will be at this height. So till this is fall of the height inside this tube. So this is called capillary depression. So I hope you understood this problem. If you have any doubt, then you can ask in the comment section. Thanks for watching this video.